Hello everyone, warm regards to you all from San Luis Potosí, Mexico. My name is Jorge Bordier and I am a master student in interdisciplinary science at the Institute of Physics of the Autonomous University of San Luis Potosí. The work that I will present has the title Study of Dynamics within a Granular Thermal Bath, which was carried out in the Complex Fluids Laboratory with my thesis advisor, Rosario Moctezuma, and in collaboration with Fernando Donado from Pachuca, Hidalgo, Mexico. In this work, we model the dynamics near the glass transition using macroscopic system. We use tracer particles to observe if decoupling exists between rotational and translational diffusion when we model the cooling of the system. The results indicate the use that the coupling depends on the geometry of the system, opening the door to future studies. Theory mentions to use the near the glass transition, where for a crystal or amorphous solid, rotational and translational diffusion are inversely proportional to the viscosity of the medium. However, experimentally, several cases have been reported where a decoupling exists. In this article, they studied if decoupling exists using a magnetical granular system and ellipses of various aspect radius on the systemized tracers, but they didn't observe the decoupling. It is complicated with the resolution of current technologies to follow the movement of a single particle when it's passed through the glass transition. That is why we resort to models. In this case, a magnetic granular model and a vibrate granular model. The magnetic granular system is composed of 1 millimeter spherical Steels balls that are in a solution of water and soap. These balls move thanks to an oscillating magnetic field generated by a pair of Helmholtz coils where the dipole moment of the balls changes and they try to follow the magnetic field. The magnetic interaction and elastic collisions also cause the movement. This model a system temperature thermal bath. We use tracer particles of various aspect radius to study the movement of the thermal bath. These tracers are floating at the mid-height of the valves thanks to the wear and the solution, favoring the collision between the thermal bath and the tracers. In these experiments, we start with a value of 10 volts or approximately 70 Gauss, and we lower this value of the magnetic field in decrements of 0.25 volts to model the cooling. We use various tracers particles with aspect radius from 1 to 7. We get the rotational and translational mean square displacement of the tracer, and we obtain the diffusion coefficients. In this graph, we can see the relation between the rotational coefficient over the translational one against the increase of the magnetic field value. We see that for all tracer sizes, we don't see a trend towards decoupling. The smallest ones oscillate but around a man value. For this system, we don't observe decoupling. That is why we resorted a second system, which is a vibrate granular system composed of 0.5 millimeters sided 3D plastic cubes, which move tanks to a subwoofer placed at the bottom, fed by a function generator. We likewise use tracers of various aspect radius made of the same cubes, but painted to be able to different them. In these experiments, to model the cooling, we increase the concentration by 20 unit increments to get closer to the glass transition. we, like we say, obtain the main square displacement and subsequently the rotational and translational diffusion coefficients. As we can see in the graphs, the relation of the translational over rotational against the increase in the concentration of cubes, we see that there is indeed a trend towards decoupling as we get closer to the glass transition. The rotational coefficient falls faster than the translational one. And for smaller thrusters, we can see it clearly. In this system, we define decoupling. As conclusion, in the first system, we don't observe the decoupling, although we can observe interesting phenomena. And the second system, we did see decoupling, which can be useful to better explain the dynamics of molecules near the glass transition. And we see that it does depend on the geometry of the system, in the first being spheres and the second being cubes. Thank you very much for your attention. For any questions, I am at your service. I hope you find the work interesting, and again, greetings and enjoy this Congress. See you.